All right, everyone. Hey, the moment you've all been waiting for, right? All right, it's 2 o'clock, and so hopefully you got your presentation uploaded. As I mentioned, if you need to make a revision or if you're late getting it up there, we can deal with it. Basically, we're going to go through all the presentations that were uploaded in the order that they were uploaded, and then we'll come back at the end and catch any that we missed. Okay, so the first one we're going to do is MCP for network management. And the second one, just so you're aware, will be secure software provisioning using something. I can't see the rest. So MCP, if that team is able to come up.
Hello, Chair. Could you please pass the slide control to me?
Okay. I believe so. Let's see. I didn't see you request. Did you request the slides? There we go. Slides.
Thank you.
Did you get control?
Yeah, I got it.
Okay, great. Okay, go ahead.
Okay, and good afternoon, everyone. And I'm Yuan Yuan, and very excited to present our project here. And our project is MCP for network management. The core problem with traditional network management is that it takes years to master complex CLI commands, but AI can learn these commands in seconds. So how do we connect them? The answer here is MCP, and our goal is to use this bridge to achieve the truly automated intent-based network management. And more specifically, we are focusing on these three key areas. The first one is encapsulating CLI commands as MCP tools, and the second one is exposing young data model via MCP, and finally enabling a closed-loop automation workflow. Here's our overall architecture works. When a user inputs a natural language command, the LLM processes it. We can then query or configure the network devices through MCP. And currently, we support both CLI and netconf connections. And now we only have one MCP server on a single device. But in the future, we want to include managing many network devices together. Now, here's an example of using MCP to query a device. On the right, you can see that when we enter user input, we can successfully get back the CLI interface configuration on the top and also the netconf configuration, including those session ID, host, and capabilities on the bottom. And here's another example. This time is to use MCP to configure a device. And on the right, you can see that before the command, the MTU of the interface of the router was 1500. And after executing the command using MCP, it changes to 800 successfully. So this is what we achieved here. And all of this is powered by natural language to command conversion. And more specifically, we've already built these core tools, and we hope to add more advanced functions like VRF, ACL, and ARDP in the future. And looking forward, our next steps include full-YARN integration for complete netconf configuration and also the MCP server discovery. And in conclusion, we are building a working bridge using MCP to connect AI directly to network management. And that's all. Thank you for listening.
Okay, thanks for your project and your presentation. Okay, so we have secure software provisioning, and the next one is SciMap. Okay. Should be able to advance the slides.
Hi everyone, I'm Shinichi Miyazawa. I would like to introduce our hackathon project, Secure Software Provisioning using TIP and Belgium. Background, Trusted Execution Environment Provisioning, or TIP, is a standardized architecture defined in RFC 9397. Its purpose is to ensure that software can be securely provisioned, updated, and managed inside the TE. In short, TIP enables remote installation and lifecycle management of trusted applications while maintaining both confidentiality and integrity. Motivation and goal. In our previous POC, we focused mainly on the message exchange using the TIP protocol. For this hackathon, we explored the challenges of building a more practical, integrated, TIP-based system. Our goals were to integrate the Belgium and open source implementation for remote attestation verifier and to deliver an application embedded directly inside the TIP message. Through this, we aim to identify potential issues in developing real-world TIP applications. System overview. Our POC follows the standard TIP architecture. It includes a trusted application manager, an attester, and a verifier. In this case, Belgium. For more details, we are going to give a demo during the Hack Demo Happy Hour on Monday and provide a deeper explanation at the last meeting on Thursday. What we learned. During development, we found that TIP protocol requires a generic IT attestation scheme to use key confirmation information. We implemented this feature within Belgium as one of its attestation schemes. Another one, when remote attestation fails, the TIP specification does not clearly define what kind of error the trusted application manager should return or how it should behave. This ambiguity makes error handling difficult. Next step, for this next phase, we plan to deploy the attester and on DRTs. Second, add support for secure updates, not just initial installation. Third, improve error handling for remote attestation failures. And finally, make the demo open source to encourage community discuss and collaboration. That's it. Thank you very much.
Okay, great. Thank you. So as I mentioned, SIMAP is next, and after that will be Yang provenance signatures. Okay. Yep. So you can just use this to advance and back.
Okay, perfect. Hello, everybody. My name is Vivek. I'm working on CMAP, implementing some algorithm and model for CMAP. So what did we do? First of all, we had some support for microseed in our lab in order to be closer to real network. Second, we focus on what if scenario, what happened for a given policy during some link failure. And for that, we implemented some link enable disable mechanism, and also an algorithm to compute the path of a packet from a VRF to a prefix. And also we start modeling the path using RFC 8345. So for our experiment, we use some operators lab and virtual lab. You can see on the left one of our labs that use microseed with a polyseed defined to go to a prefix defined on router 1 from router 3. A very simple policy. We go to 2, to 5, and then to 4. And on the right side, we have the CMAP model. So we have this policy model supported by IGP layer. In this case, it's ISIS. So if we try to model the path on the ISIS layer, before the failure, it just follows the directly connected link. So for segment 1, we only have one supported link, so link between 3 and 2. And so on for the other one. But if we remove the link between 2 and 3, they are not directly connected anymore, and we need to compute the shortest path between 3 and 2. And as you can see there, segment 1 is now supported not by one link, but by 3 links, link between 3 and 6, 6 and 5, and 5 to 2. We saw that modeling paths using RFC 8345 is a good approach for basic example, but when we start modeling, for example, policy with multiple candidate paths with different preference or multiple segment lists with multiple weight, we can't model it with IETF topology in our model. And the goal for next hackathon is to use the model defined in draftable and CMAP Yang and try to see if it's good, and also continue looking for gaps and implementing candidate. And also keep in sync with ISIS topology in a model and continue extending the path computation algorithm, adding specific computation using external relationship mechanism. And this is our team for Hackathon. Thank you.
Okay, great. And thanks to the presenters too for keeping your presentations concise. Okay, Yang provenance signature, and after that will be radius updates.
Okay. Thank you. Well, basically, the idea we have continued. This is the third or fourth iteration of this work in the hackathon. The idea is that we are trying to enhance data that is shared, telemetry or configuration or control data that is shared using Yang, by providing signatures that guarantee their origin and integrity, applying provenance. And this is something that has been, well, it's part of a result of the work in the draft that is precisely titled Yang provenance. What we brought here is, well, we keep enhancing the library that is used for providing Yang signatures, and this as we make the draft evolve. And in this case, what we have worked mainly has been enhancing how the model for the procedures for model augmentation, formally allowing that there is a better formal integration with Yang practices, and in particular is using the schemas directly for providing the signatures or verifying them. And to demonstrate this and to make this clear that we are following a full schema-directed mechanisms for signature generation and verification, what we have used is we have connected the the signature generation and verification mechanisms that we're providing with the library, with the Kafka schema registry that is being discussed in another draft based on MMOP that uses advocates for using Kafka and the Kafka schema registry for being for providing telemetry mechanisms in support of network management. Basically, what we demonstrated in Madrid is what is in black in the diagram, and what we have added here. We demonstrated in Madrid that it was possible to make this integration in the Kafka workflow. What we have made here is, as I said, is that since we have implemented mechanisms that are schema-driven, the schema is derived from the schema registry that is available in Kafka. The signature is generated, and whatever the verification is based as well in the schema. So the whole library is now independent of a particular way of associating the signatures to the Yang model, and now depends on how it has been defined in the schema and can work by exploiting data in the schema. Finally, we tried this. We have demonstrated the evolution of the reference implementation of the draft and enhanced what we brought to Madrid in terms of the integration with the Kafka. And we have identified a couple of other scenarios in which this could be applicable, and we are going into enhance this and demonstrate it to some people that were around the table how this could be connected. Because among other things, what we have is a much cleaner way of connecting with the Yang registry, with the Yang schemas. Well, in the future, the idea is to progress in building the provenance path and keeping an updated reference implementation that helps us in demonstrating and validating what we're saying in the draft. And that's all. Thank you.
Okay, so we have radius updates, and after that, we have SRv6. All right, you can just control the slides.
Okay. Hello, my name's Alan, and I do radius. So the problem is signaling is very, very bad in radius, designed in '93. It's been around for 30 years. In some cases, you are supposed to throw away well-formed packets which are authentic and from known sources. This is pretty terrible for a whole bunch of reasons. So the clients have to retry because it's all over UDP. There's all kinds of issues with multi-layer proxy chains. And because it's a 1993 protocol, there's an 8-bit ID space, which gets used with packets that are still outstanding, and it's really terrible. The solution is a new packet type, which says, yeah, I received your packet and I don't know what the heck to do. Please send it somewhere else. We've implemented that in FreeRadius, RadSec proxy. The Radiator team's looking at it and Cisco's looking at it. We found a bunch of corner cases in the current spec, which is a draft, which we have to address. And we found some other things and implementations we need to fix. And we're going to discuss the rest of it at RadX on Friday. We also had a good discussion with Cullen Jennings about Quick. We might decide to use 2020 security protocols. That would be a step above UDP. We are working on TLS biz, but that's it from us. And so we have to figure out what we're going to implement next. Thank you.
Okay, we'll have SRv6, and then after that is SCONE.
Hi everyone. Our theme is SRv6 SFC architecture with SR-aware functions. This is our objective. We want to get the comprehensive management of SRv6 SFC using a controller. SRv6 controller computes SR policies based on network function information, and SRv6 manager deploys network functions and configures SRv6 endpoints, for example, end-to-end, and so on. Our hackathon goal is implement SRv6 SFC path computation in following OSS. First, we implement root source routing path computation for SRv6 SFC in Polar PCE. And second, we update BGPLS service segment API for GoBGP version 4. And we implement a manager component for initializing network function and setting up end-to-end. This is our architecture. And the concept, the controller manages the entire SRv6 SFC network. And we use these protocols, PSEP and BGP Prospect and BGPLS. We implement the gRPC API for BGPLS service segment to support GoBGP version 4, and we added support root source routing. This is the components. And okay, this is result. We achieved the deploying virtualized network function to OpenStack hypervisor, and we achieved the deploying the SRv6 settings configuration to this network function. And second, this is the topology of PCE. This path achieves the service function chaining red, blue, red, and green. The left side is input YAML, and the bottom is generated SR policy. And right side is PCAP. So we completed all of our objective. These are our code. Thank you for listening.
Okay, great. Thank you. And let's see. Okay, so Scone, and then we have multi-CDN after that. All right. You can use these to control the slides.
Hello, I'm going to talk about Scone interop at this hackathon. And Scone is a simple protocol, so we just have a simple one chart briefing. There was a healthy group of us here from a number of different organizations this week, and we had both client and server implementations and Scone network elements present, and some remote participation from Germany. So we were actually able to flow Scone packets over the internet for the first time, I think, and they survived between the test network here in Germany. We also had a Scone client integrated with a Facebook app on an Android phone, and that was working with Meta's Facebook servers on some video flows through the Ericsson Scone Enforcer. So we had overall very successful set of tests. We made some progress on PRs to different open source projects. And we're well set up for the Scone meeting later this week to make progress in getting towards a working group last call on our protocol draft. So that's it.
I think I remember seeing that Scone on the table earlier. So I don't know how many more times I'll have this project, but you may want to hurry up and come to the next one so you can be a part of that. Multi-CDN is next, and then after that is PQ and X509.
control the slides, just forward back. Okay, thank you.
Hello, everybody. I'm Jishan, and today I'll be talking about multi-CDN. So first of all, before we talk, why do we focus on multi-CDN? As we all saw with the recent AWS outage, from a video streaming perspective, relying on a single CDN has some risks. So you must have a strategy to intelligently route between multiple CDNs in real time. And for this hackathon, our plan was to dynamically select the best CDN for any client in real time. We already have a DRL-based solution, and the plan was to integrate it into dash.js. And we also relied continuously monitoring CDN states in real time just to get the states for a client, create some overhead. So in order to avoid that overhead, you could also use forecasting to predict what is going to be the next CDN state. And relevant RFCs are 9317, which has some guidelines for using CMCD and CMSD for improving client QoE, and also the content steering draft and the ETSI content steering standard. And on the right, you can see our solution. Generally, we have multiple CDNs and a content steering server. And our AI-based solution implements on the content steering. And you can get metrics from the client using CMCD. And you can get CDN logs using CMSD. And based on the CDN states, the AI agent outputs to the client which is the best CDN for it. And we also integrated the solution into dash.js with some GUI enhancements, which was real-time throughput tracking, RTD tracking, and stall tracking for each CDN, and also the real-time forecasted states for each CDN. And we also added the option to select any CDN strategy that you want. And if you want more details on the solution, you can refer to our paper Streamvoice, which was published in ACM Multimedia Systems. And this is a screenshot of the demo. As you can see on the right, we have the real-time throughput tracking and the RTT and stall tracking, and you also have the actual state of each CDN plus the forecasted state of each CDN. We weren't able to tune perfectly the forecasted state of a CDN, and we're still working on it. And if you want to check out the demo video, you can access it through this QR code. And during the hackathon, what we learned is that global efficiency is not an emergent property of a purely local optimization. So right now, what we're doing is just optimizing the QoE of a single client, but from a multi-CDN perspective, which was designed to handle clients at scale. If you have just a single agent deciding the best CDN for each client, you will just end up with overloading the CDN, and it will no longer be the best CDN. And the upcoming work is a multi-agent DRL solution, which can balance global QoE trade-offs. And a huge shout out to my team members, Dr. Abdullah and Parsa. And that's it from my side. Thank you.
All right, fantastic. So PQ and X509, and after that will be knowledge graph.
Hello, I'm John. I'm representing the PQ and X509 group. Yeah, so this project's gone on, I think this is our 11th hackathon. So basically we got together and we want to do interop testing with these new PQ algorithms, test them with signatures and keys and certificates and all that fun stuff that the world runs on. The cool thing with this slide is when we started this, we give feedback to all these different drafts. You see some of them have turned into RFC, so this is great to see. And we'll continue to do that testing. So what got done this hackathon? So just a couple weeks ago, the composite signatures draft RFCs got official OID, so yay. And we had 6 different people or groups basically implementing them this time at our hackathon. So Max and Felipe have one, Dan had one. So you see the little picture there, that's the people collaborating together. Crypto4, I had JP Zane, Will and Andrew. I did one from Entrust, James T did one from CHT, and Alex Zed had from SafeLogic. So a lot of people want to get these things interoperating. Also for the composite chem implementation, there's some interop going on there as well. That draft is currently in working group last call. So what else got done? So the drafts, we've been working on this project about 2 or 3 years now. So some draft maintenance updates to the repository. So Alex and I had a good discussion on the CMP test suite augmentation. Actually, Chris is doing some cool statistical analysis of rejection sampling in MLDSA. And also, Dan has been doing some work on doing automation for the CMS test suite. So there's a lot of different kind of PQ test suites going on with these protocols. So what we learned, As I said, there was a lot of work done on the composite signature stuff. So what we learned, it's the latest draft is fairly easy to implement. The most difficult part has been, doing integrations with the different crypto libraries that implement the underlying algorithms. And one other thing is the composite chem private key format is in quotes, a bit annoying because it includes the public key, but nothing really, no real roadblocks or anything. So I just have a couple slides here. I'm running out of time, but so if you go to our page, we have lots of different kind of results. So there's an example of PQ signatures and interop we do. You can click on any one of them and you'll see all the test results for all the people that have implemented them. So here's an example of NLChem, the interop that's going on with that. We have the composite chems as well. There's some interop there. You can also see composite signatures. This one's a work in progress. A lot of us were just doing the latest update with the final OIDs, so that's why you see that one. It's not filled out yet, but it should be soon. And then, yeah, so in summary, this project continues. We have monthly meetings. The next one is December 2nd, so you're all welcome to join if you want. We always want more implementations. We had some new first-timers, so Yug and Will joined us this time. And yeah, it's a lot of fun, so come join us. And yeah, that's it. Thanks.
Yeah, great, thanks. Probably one of our biggest success stories too in terms of supporting remote participation and the use of Gather for helping with that. So knowledge graph for network optimization, I'm guessing, and then Roka's after that. Operations, okay.
Close. Hi, everybody. My name is Wakabaki. I'm here representing the people you see listed here who did the work, and I'm taking the credit. What are we trying to do? Well, we have a network knowledge graph design team, and we met in Madrid, and out of that meeting, we had the idea to go off and create an initial POC fusing the early CMAP model that you saw earlier with the Noria O incident model that was created by Orange Research to illustrate how existing work within IETF can be quickly integrated into an existing ontology, extending that with new knowledge. This is Noria. You can see it's incredibly complicated. The key point to look here is there's a network part, there's an application or service part, and there is a dynamic part, which would be the trouble ticket or the events coming from the network. The key point here is the network data. We replaced that. We created a RDFS version of the CMAP model that represents the topology. We aligned the two ontologies to show how the data can be linked. And what can we do? Well, obviously we can query the CMAP data as a knowledge graph and get some really cool information there. But that's not really what we wanted to show. We wanted to show how you can take existing models and existing work within IETF, you can put it into a different format, you can augment it, you can treat it like a knowledge graph, and you can enhance it with new information. So for instance, here we have a trouble ticket within an OSS system defined using Noria. So a new problem comes into the network, there's some issue that gets associated with parts of the network defined using CMAP, which would have the links, all the links that CMAP has of external references to different parts of the other Yang models within IETF. And of course, that then leads us to the a way of defining the contact and the poor guy who's responsible for the problem. So the idea, as I said, is try to create existing knowledge graph and create a knowledge graph from existing information within IETF. Next step is to essentially build on this and to build a workbench that we can explore. So if anybody's interested in working on this, please get in contact. We're meeting and discuss a bit more on Wednesday at Emma.
Okay, thank you much. So next up is Roka, and after that is Kira. Roka, okay.
Hi, hello everyone. My name is Yuto Nakano. So I would like to present the RockIS in parallel mode. So RockIS is a very fast 256-bit symmetric key encryption, and it based on the sponge construction and takes 256-bit key and generate 256-bit tag, and it can be used as an AED or encryption only or key stream generation mode. And it has 256-bit security, and draft is available in the link. So in this hackathon, we implement the RockIS in parallel using the AVX 512 and to achieve even higher performance. And so we implement two versions. One is RockIS X2, which is 2 parallel, and another one is RockIS X4, 4 parallel version. And using the high AE benchmark, did the performance evaluation. So this is the result. SX2 can achieve more than 572 gigabps, and SX4 can achieve 955 gigabps on AMD CPU. So very fast, and fastest in this is the SX4, faster than high AE in 4 parallel mode. And so the detail of the parallel mode is not available in the specification, but I'm planning to update the draft, and also I will upload the source code to the GitHub. So if you are interested in, please check the link. And this is the acknowledgement. Thank you. That's all.
All right, so we have Kira up next. And after that is AI Network.
Yeah, hi, I'm Roland. Okay, so Kira is basically a scalable zero-touch routing protocol, and we brought an implementation in Rust. So there's a draft out there that's not yet somehow worked on in the IETF. So it's an ID-based routing protocol and uses path IDs for forwarding, which works with ordinary IPv6 forwarding. We do some testing in Nest, which is the network stack tester. And the plan was to debug the forwarding table inconsistencies. We have or maintain a 2-hop vicinity graph, and there seem to be some inconsistencies that we want to find out. And additionally, I worked on supporting multiple paths. What we got done is we achieved some progress in that forwarding inconsistency issues and detected that the connectivity problems basically showed up in larger topologies. And so some of the links were missing in the 2-hop vicinity. And that was mainly due to the fact that the nodes were not able to respond in a timely manner. So if you're starting too many nodes on a single machine, then that's probably causing some timing issues. So that was not an implementation problem. And I also finished the implementation of some path collection structure. So we were a very small team. So Julius was remotely online. Second IETF hackathon, thanks for that. And I was here on site, obviously. So next steps is to achieve a reliable full connectivity with Kira, and then also working on the dynamics. There will be a site meeting on Thursday, so if you're interested in working on that, so that next hackathon, maybe more people are involved, then come to the site meeting. Thanks.
Okay, great. So AI Network, and after that we have Packet Scope.
So hello everyone. Our project is AI network. We call it the IETN as a mouthful. The idea is we're trying to build an AI network that facilitates AI services. Those include training, inference, and agentic operations. So we're not limiting it to a specific application here. It's more generic. It's trying to glue everything together. It's trying to bring all the players in the AI together. Those players include data providers, model providers, agent providers, compute, resources, etc. And it has different components. It has a core that carries a lot of the intelligence and makes this work together and glue together. And it runs on top of enablers. And it's composed of control plane, data plane, OAM, and intelligence layer. This is just at a high level. So imagine that you have all those components, players, data providers, model providers are scattered in a network or a cloud, and you're connecting them together and allowing them to provide services. So clients can come and interface with this to ask for training services, agentic services as well, etc. So what we did is we're trying to build a platform at the moment. So this is what we have so far. We have interfaces for the clients as well as for the providers. You're seeing here data providers, compute providers, and agent providers. There is also the interface for the clients. They can ask for training services and inference services. And we built a toy example here. It's related to distributed training. So the challenge is how do we select the best subset of data sets suitable for training a specific AI? And we devised a quick solution. It's based on something called NWT. We collect some mini batches and we run some algorithm and then we make decisions. So those are just results. So things are working fine. But what exactly do we want to do next? There are some engineering tasks associated. So we want to develop appropriate communication protocols between the different components. We want to support interoperability with other agentic protocols such as A2A, MCP, and ANP. Some security and privacy considerations need to be handled, and of course, adding new services. A lot of research also is required, data descriptors, intelligence layers, algorithms. We do have a side meeting tomorrow at 11:15 a.m. Please come for further discussions. Thank you.
Okay, thank you. And all right, so packet scope and L4S will be after that. Control the slides with this.
Hello, everyone. This is our IETF project, packet scope, empowered eBPF for protocol stack defense. So what problem are we working on? The traditional network stack is a black box which causes two major pain points. First, it's difficult to diagnose. Performance bottleneck like latency and packet loss are hard to pinpoint, and the packet paths within the kernel are unclear. Second, it's difficult to defend. It's hard to detect modern and stealthy attack like cross-protocol or semantic attacks, which traditional IDS and static rules miss. It's also hard to block because a gap exists between detection and response. An admin should manually write and deploy complex rules, which is simply too slow. So what have we achieved in the hackathon? We successfully deployed packet scope on our server. We deploy and monitor live traffic on the test network with our analyzer module. We also validate the guardian module, achieving a seamless integration of eBPF and LLMs. The eBPF components using XCP provide zero copy, zero latency data collection in the kernel. The LLM components using long context reasoning on this data to identify tilty attacks. Together, we built an intelligent defense loop. The IAM analysis thread and auto-generate eBPF filtering rules. These rules are then hot-swapped into the kernel's ITB hook. We successfully using this to auto-detect and block an SAMP flood attack in our demo. So for the highlights, we have a few lessons learned. First, IAM with eBPF is a new paradigm for network defense, shifting security from passive response to intelligent and real-time blocking. Second, IAM solving a hard-to-block problem by auto-generate process rules, which significantly lowers the operational burden. And third, SDP provides zero latency and zero latency defense by dropping malicious packets before they even enter the stack. We also have some feedback for the working group. We hope to see more flexible eBPF hook for modern protocols, such as Quick and HTTP3. Finally, our conclusion of future work. For future work, we plan to extend tracing application layer protocol like HTTP2 and Quick. We also want to build cross-hop correlation for distributed tracing and analysis. And importantly, we will using BTF to enhance the compatibility. Our project is available on GitHub, and the demo URL is out here. Thank you very much.
All right. So L4S, and after that is quantum. All right. Oh.
Hello, I'm Greg White from Cable Labs. We had another iteration of the L4S interop at the IETF Hackathon this weekend. L4S, if you're not familiar with it, is a low latency, low loss, scalable throughput, congestion control architecture for the internet. We worked on looking at interoperability between different implementations of L4S, both at the endpoint applications as well as in the network. And in addition to that, the TCP accurate ECN and the version of accurate ECN for RTCP, which is RFC 8888. We had several congestion control implementations participating from Netflix, NVIDIA, Chrome/Ericsson, and Nokia's Prague congestion control modules. In terms of networks, we had mainly simulated network environments on the table over here. We also have Wi-Fi AP available with L4S support. As in previous iterations, we're not stopping today. We're going to continue testing in the shared workspace through Thursday this week. What got done so far, I guess maybe one point of the newest news is that libWebRTC now has support both for L4S on the receive side, so sending the RFC 8888 feedback, but also now on the send side. So it has a L4S congestion controller built into at least an experimental version of it, and that's available in Chrome Canary with appropriate command line flag. You can enable that. And it's using the Scream congestion controller from Ericsson. In addition, there was testing done using Chrome to be the receiver of a Netflix cloud gaming stream as well as an NVIDIA cloud gaming stream using their production servers. Through that testing, we noticed a couple of issues and a couple of bugs have been filed to resolve those. Netflix, in addition, tested their rate control algorithm against their production cloud gaming service with multiple different flows, different encoder configurations. And then lastly, the Prague congestion control module, experimenting with some new growth algorithms, which will be discussed further in ICCRG. Some nice graphs, which I won't have time to go through, but feel free to look at afterwards. And then the list of participants, several in person and several remote as well. So thank you.
Okay, great. So we have Quantum and IPv6 Web Resource Checkers after that. Okay, great. Okay. Control the slides. Right.
Hi, everyone. I'm Monet from Keio University in Japan, and I'll be representing the Quantum. Okay, so for our plan, we haven't necessarily been working on a specific hacking project, but we have been gearing up for a set of network specifications that we have been recently working on, which we hope will become RFCs, some of them eventually. And the initial target that we're working on in our project right now is more so data center scale and multi-computer interconnects, but we are very much interested in wide area networks, and definitely there are some overlap in the specifications that we're working on. So some other plans that we had are learning more about SRv6 and some other technologies that might impact our network design, and also learning about PQC and other things that Quantum might affect. So this is like an overall scheme of our specification set that we're working on. This is just to give like an impression of what the structure is, not necessarily to read all of it. It's very tiny. We have a couple of documents that are already available, but the blue ones or the purple ones are the one that we have been focusing on recently. So some rough equivalents are like host requirements, network architecture, and physical layer, which won't be in the scope of IETF. We have some currently publicly available documents, two RFCs from QRG, and also 3 publicly available documents from our group back at Keio. These are more so like an approach rather than a community consensus. So if you're interested, please check that out. So we have more specifically been working on quantum network architecture, QNode, which is a quantum node specification, and also EPPS, which is a certain type of node type in a quantum network. And we have also been learning about some technologies like message brokers and the Spanish network design from our friends, and also sharing our network design. To wrap up, I'm representing myself, and also Rod Van Meter, my professor. And we had some nice discussions with Diego and Melanca Lopez. And just to note that we have a QRG meeting tomorrow morning. So if you're interested in quantum networking or you want to contribute, please come to that. And just to put in some advertising, we have 3 software packages from our group. One is a quantum internet simulation package built on Omnet. And also we have 2 libraries that are for controlling more of the physical layer. We have a test bed back in Japan, so this is to control that. We have control devices and also a TDC toolkit, which is like a high precision time tagger used in our test bed. So that's pretty much it. Thank you very much.
Okay, thanks. And all right, so IPv6 Web Resource Center, and after that'll be DNS over CoAP. Control the slides right here.
Yeah, so I'm presenting the IPv6 Web Resource Checker, a very practical thing for a very practical problem. So when really trying to deploy applications for IPv6, the question that always arises is, will my application, in this case, a web application, work with an IPv6 only client? This has especially become important since the US governmental IPv6 only mandate, where you can't be really sure that your application gets flagged as IPv6 ready unless it's really working in IPv6 only environment, and probably also an IPv6 only environment without any IPv4 connectivity. And so if you want to answer the question, is my web app IPv6 only ready? The question is, it's really hard to answer because web apps use resources from many sources, and they're composed dynamically. So the only chance of really being sure and checking is actually drawing it into a real web browser. And this is hard for many client devices and in many networks, especially in corporate networks, because you need stable dual-stack connectivity to really simulate that. So what I got done, we released a Selenium-based test service that allows you to check whether your website or web application is IPv6 ready by really crawling the page, getting all the resources, analyzing the performance logs, and getting the information out whether all resources have been loaded over IPv6. Released last week the stuff on GitHub, and we now have a publicly available demo, so you can try it out yourself. And during the hackathon, we did a few more improvements on the open source project. So if you want to know, this is what it looks for several websites. So we can see the IETF website is IPv6 only ready, while, for example, GitHub is not. And here you can really see which resources got loaded over v6, which resources got loaded over v4, and where you need probably to ask your suppliers or component suppliers where the lack in IPv6 is so far. Of that, we're done.
Okay, good to see that the IETF website's in good shape. Okay, so we have DNS over CoAP, and then testing congestion control will be after that. Just use that.
Hello. I continued my work from Madrid and Bangkok to get DNS over CoAP into Unbound. I just see the version number in that draft is quite outdated. We are at 20 now, but yeah. Some of the to-dos are not marked. Okay, that's fine. So basically we got already done in Madrid the make OSCOR and credentials and CoAP resource paths non-constant and configurable, but not had the reuse TLS PKI for DTLS done and find out the bug with these piggybacked ARCs. I got done today and yesterday the TLS PKI integration into DTLS. That it's not visible on the slides, but well. So basically it's only this little bug in libcoap, but I'm in contact with Olaf Bergman, the author of libcoap, to figure this out. So yeah. What we learned is we need to find the right mapping between the unbound and the libcoap variables to get the TLS intermingle with each other, and but once found, the integration was rather quick. And so to wrap up, these were our team members. Most of the work was done by me, but I had contact with the Unbound team via Yorgos and with libcoap via Olaf, and the original student who wrote this is Philip. For the future steps is to fix this remaining issue, get the PR merged, and maybe find some future extensions in the DNS over CoAP suite that can get into Unbound. Thank you.
Thank you much. Okay, testing congestion control, and after that will be COSE PQC. Control slides right here.
Good afternoon, everyone. I'm Vishal. We're representing 10 students from NITK Sirotko. All of us are first-time participants, and during this hackathon, we worked on testing congestion control as well as queue management algorithms. In our amongst our 4 objectives, we were able to successfully complete 2 of them, partially complete 1 of them, and 1 of them is still ongoing. So with our first objective, we tested the FQ-Codal algorithm RFC 8290 as versus the FQPI algorithm, which is currently an active internet draft in TSVWG. One of the main goals of our experiments was to test on a live test bed using the QQIW235 access point. Thank you to Con Riley and the rest of the NOC team for helping us set this up. We mainly ran the RUL real-time response under load tests from Flint, and we aggregated these tests with graphs based on RTT as well as throughput. And for the rest of the results and other experiments we conducted, we invite you to TSVWG tomorrow for a presentation.
So as part of our second objective at the hackathon, which was to develop a Nest-based AQM evaluation suite, which was compliant with RFC 7928. And so besides the standard dumbbell topology, which is used for the evaluation of active queue management algorithms and congestion control algorithms, we referred to the literature in the past, and we decided to use the generic fairness configuration 1, that is GFC 1, and GFC 2 to evaluate the AQM. And any feedback on these given topologies would be greatly appreciated. And if you could join us for the CCWG session tomorrow in the morning, that would be great. So there were 3 questions that we found a bit difficult to answer, which are listed here. So first of them was, what are the recommended or the standard topologies to evaluate multi-path transport protocols? And then what are the standard or recommended performance parameters that we should focus on for the multi-path protocols? And how to go about comprehensively testing the congestion control and queue management in multi-path bottleneck scenarios.
Good afternoon. I'm Himang, and along with me and 2 other people who are attending remotely, Alan and Smith, we are building a congestion control evaluation suite on Nest. Nest is a Python package that allows you to set up real-time test beds using Linux network namespaces. The evaluation suite is going to be compliant with 9743, and we're looking for feedback on the design, and the QR will take you to a design doc that we have prepared. Thank you.
Ambitious, 3 presenters in 3 minutes. You pretty much did it.
Hi, Charles. Can you hear me?
Yeah. Are you presenting Kosei?
Yes. Can you just advance the slides?
Okay, sure.
Okay. So, hi, everyone. This time I'm participating from remote. I was working on the CBOR object signing and encryption, BQC, post-quantum crypto extensions. Next slide. So the COSI working group is working on a number of algorithm extensions, post-quantum crypto algorithms, namely MLDSA, FNDSA, and SLHDSA. You've seen these algorithms presented also in the previous presentation on X509 as well. So there's nothing special there. It's all over the place in the IETF. And so I was asking myself before this weekend, why not to add them to one of the libraries, Lawrence Lundblade's library, the DCOSI library. And so I thought, as a plan, I would quickly start with the MLDSA and then add the other algorithms, because it would be useful to have test vectors and examples in those documents, IETF specifications. Next slide. Yeah, and then the reality sets in. I used code of my student, Elona Krasniki. That was really helpful to get started. The library uses liboqs for the implementation of the PQC algorithms. While not ideal for IoT implementation, I think it's a starting point. There are obviously better optimized algorithms. But I think this is a common thing among all the projects. It always takes longer than one would think. I was hoping to benefit from the AI developments, and that would quickly help me to write code faster. But probably due to my skills with prompting, it more produced more bugs than useful code. But I still managed to get the stuff working, but only for the MLDSA and not for the rest. So the integration in DCOSI with different crypto libraries was also a little bit more complex than expected. I will publish the code once polished at Lawrence's GitHub repo so that others can use it as well. Next slide. And this time I was only on my own, although I successfully distracted the RATS group from making any progress in between to have some discussion partners. I still plan to implement the rest of the algorithms because I think it's useful to have those, obviously. I will, next time, since I saw the presentation from the BQC X509 team, and that team looked really fantastic, I'm going to join that team and work on this stuff there. And hopefully there are some other implementations out there doing BQC integration into COSI libraries. So I will test with them. Thank you all. See you next time.
Okay, great. Yeah, thank you, Hannes. Okay, so next we have, wait a minute, where was I? Oh, validate network telemetry, and DKIM2 will be after that.
Okay, thanks. Hi, everyone. I'm Yannick, and presenting the results of our project Validate Network Telemetry Message Implementations. Our plan was actually to validate 2 data collection implementations, NetGoes and PMACCT, implementing the telemetry message draft. You have one repository that contains the packet captures used to reproduce the telemetry to the data collection, and then on the second repository you have the generated output of those data collections that we then validated together with the Young schemas. This is the overall big picture on how this fits into the Young push to message broker integration. So for this hackathon, the relevant documents are highlighted in yellow. And this is the first result for PMACCT, where the development was just done during this hackathon, basically. And exactly, yeah, what do we see here? Yeah, so you see the whole output is very small, but yeah, exactly here. So we found a few errors then. This shows how variable the whole validation is. Especially, so here in this case, it was about any data that would expect an object. And then here, the classical thing is about timestamp formats. And then another one was about namespaces that get lost when including the original message into this new telemetry message. And then for NetGoes, we did the same, actually. And exactly how does it fit in the action items we had from last hackathon? So we got from SESNet some improvements in Young Lint that we were able to also validate the Young structures. Big thanks to them, and also to PMACCT, to Paolo Lucente for his work on the collector. And then there's still some stuff left about supporting Young features. And then in next hackathon, we have still some new action items now. So it's about any data in Young structure that needs to be validatable in Young Lint. And then also these few fixes that we identified. And finally, this is the team that contributed in this hackathon. And if you're interested in the topic, these are the different meetings throughout the weeks. Thanks.
All right, great, thank you. Okay, DKIM2 and dry run DNSSEC will be after that.
All right, thank you. I feel like I have a lot less to present than a lot of other people. DKIM2 is a replacement for the existing DKIM mechanism for signing emails. And so we have some early stage drafts that were maybe not ready to be actually worked on yet. So we wound up doing quite a bit of work just improving the design of it. Based on the experience, we changed the format a bit. So we had a bunch of people each developing against different versions of the spec, which means we didn't get to interoperability test against each other, but we're hoping to do more of that during the week. We certainly came up with more to discuss in our session on Monday. We learned that it's good to come prepared, that our existing libraries could be repurposed pretty easily for the new work we're doing, but the specs were a bit fuzzy on the definition of how to do things, which we quickly realized we need to specify things a lot more exactly, or we're not going to be able to interoperate. So the hackathon was very useful for finding those things out. We had those of us listed here, plus some other people who were sitting at the table and hacking on bits and pieces as well, but these are the ones who joined the Zulip room, so I knew how to spell the names. Join us tomorrow at 5 p.m. Monday, where we're going to be working on this some more. Thanks.
Hey, yep, sorry, it wasn't more successful in some ways, but very successful in others, right? Getting, learning that stuff early on is going to be really helpful. Okay, the dry run DNSSEC is next, and then another DNS miscellaneous projects will be after that.
Yeah, thanks. Hi, I'm Euros. I was working on implementing a dry run DNSSEC, the drafting Unbound. I started the proof of concept, and I already can configure some trust anchors that will behave the way that dry run DNSSEC mandates. Yes, this is only with configuration options locally, so not live yet, but there's still a lot to be done. It's DNSSEC. That's it. Thanks.
Okay, well, thank you. So we do have another DNS-related presentation, DNS miscellaneous projects. And after that, we have secure hybrid network monitoring. Yep, there you go. All yours. Control it here. Okay, thanks.
Hey, folks. I'm Shimon, and I'm going to give an update on a set of projects undertaken under the umbrella of DNS. So you already heard about DNS over CoAP and just now Yorgos on a dry run DNSSEC. This, I guess, is the rest of the DNS projects. So let me go back to this slide. This is the set of folks that were working across 2 different tables, and I just want to quickly apologize. I left inadvertently one name off, Casper Schutitzer, so we'll fix the slides promptly afterwards to make sure you're there. So there were a range of projects done by miscellaneous people in this group. First, a set of people worked on implementation of the DELEG protocol. That's a new, if you're not familiar, that's a effort underway to define a new way to do DNS delegation. There was work on implementing DNS transport signaling, which is described in a recent draft. One member of the team worked on integrating libuv and the OpenSSL library's quick support as a proof of concept for the ISC bind DNS server. There was work done to implement what's called the poison, let me see if I can pronounce this correctly, poisonlicious draft. So that's basically a protocol to share DNS resolver caches, and that was also done for the ISC bind server. And as usual at the DNS hackathon tables, we had extensive discussions about various internet drafts and also proposals for at least 2 new drafts that I heard about during the course of the weekend. And there was a bunch of work on post-quantum DNSSEC, so setting up DNSSEC testbeds for PQC, as well as some preliminary work on implementing support for the MLDSA signature algorithm for Merkle tree ladders. And I think that's all I had.
Okay, so secure hybrid networking, and after that is SCHC management.
Thank you. I will introduce briefly about the secure hybrid network monitoring project. So we are working to make a system for monitoring characteristic of hybrid network deployed across hybrid and mixed cloud environments, especially on the security aspect. The characteristic includes geolocations, operators, or link quality, or tunneling protocol properties. So for more details, please see the previous hackathon slides available on the internet. And we have currently 2 internet drafts submitted and available on the data tracker. So in this IETF hackathon, we have started to implement the core functionality of our system, especially the core function of acquiring telemetry information from nodes along the path. And we examined use cases following the previous IETF hackathon and confirmed this system's in some sense usefulness. So we are making 2 use cases, and we will show the first example. So in this setting, we have 2 possible BGP passes to go through R1 to R2, left to right, but we have 2 intermediate routes, and the top one is acceptable route, and if switched, the second one, it is unexpected route, and we should detect the anomalies. So we implemented our system, preliminary system, and if we can assure that our system can detect the anomalies real time on the systems. If you are interested, please visit our booth to see our demos. So you can see how the route is configured, and which is either it is acceptable or non-acceptable passes. So in the next one, we will implement more features on the PCS functionalities and provide the technical feedbacks to improve our internet drafts. Thank you very much.
Okay, so now we have SCHC management, and after that is 5G I2NSF. So SCHC, okay, I see it coming up, great. You can just control the slides right here.
The arrow keys, yeah, nice, thank you. So hello everyone. My name is Javier, and we're in SCHIC working group. So we're doing core conf management. So first of all, what's SCHIC? It's static context header compression mechanism. So it's based on a shared set of rules. Usually it's static, so it's not supposed to move during the communication. And like this, we can compress like internet packets. And it was initially developed for LP1. But now it's been getting attention for other environments. So we have to adapt dynamically to like changing traffic. So how we planned to do this was implementing CoreConf. So it's network management for constrained environments. It implements YANG, SID, and co-op interface, and codes in CBOR. So it achieves like it's super efficient. And we have a draft on how we apply it to SCHIC here in this draft. And yeah, so the idea is that we introduce management traffic to control the set of rules or the context between the endpoints. So yes, we managed to do a POC integrating CoreConf in a SCHIC endpoint. We handle fetch, IPatch, and RPC operations, and we managed to manipulate remote context. So this enables us to make, for example, more efficient compression based on evolving traffic, like ongoing traffic. And we are also working on optimizing rule management in a hierarchical tree structure like this. So it follows kind of a binary tree, and it's sufficient to find the rules. So yeah, in our proof of concept, we managed to like begin with a very generic rule. So we managed to go from a packet of 72 bytes. We compress it into a 43 byte packet. We send that. After that, we send the management request to modify that compression rule. So here you can see it coded in CBOR. This is like a debug format. And then finally, we're able to use the new rule and achieve better compression. So that's it. Thank you so much for your attention.
Okay, so we have the 5G I2NSF, and after that is ILNP. Control the slides right here.
Hello, my name is Joseph Ban from Sungkyunkwan University, and our project champion is Professor Jeon Porjong, and we're going to talk about 5G I2NSF, an integrated security system for 5G networks with I2NSF. And this is the poster detail about our project. And the goal of our project is to make an integrated security system in 5G network with the I2NS framework. And we focus on security policy provisioning through the edge-based I2NS framework. And you can see the detail about our project in the internet draft. And this is the detail about what we're doing. And as you can see on the right side, this is a function of the 5G I2NS security system. And we can connect it with the 5G core network. And with that, we make the NSF inside the UPF, and with the NSF, we can manage the UE accessment to the network data network. And as you already know, the I2NSF is the cloud-based approach system. So while the UE handover from one GNB to another GNB, to check the NSF, it has to check the NSF in the cloud. So it can make the long delay by a detouring path from UE to I2NS cloud. But this is why we want to try to make this 5G I2NSF system, which is the edge-based approach for 5G network. So as you can see in the image, so we make the NSF inside the UPF. So while inside the UPF, so you can make the short delay by optimal path from UE to I2NSF edge. This is the 5G I2NSF system approach. As you can see on the right side, the policy can be translated from high level to low level, and it can be given to the NEF in the 5G core network. And after that, while the UE moved to GNOD B1 to GNOD B2, the policy migrated from UPF1 to UPF2. So before the UE handover, the policy migrated, so the NSF can be generated in the UPF2. And what we learn is we learn about the design and implementation of the I2NF on the 5G network with the Operate 5GC. And this is demonstration what we've done, and this is open source, and this is the demonstration of the video clip. And the next step, we will convert the YAML and XML data model to YAML data model in I2NSF, and we'll design the implementation of 5G protocol. And you can check about the hackathon project detail about in our draft. And this is our hackathon team, and you can check detail about the appendix. Thank you so much.
All right. All right, so we have ILNP, and after that will be a Yang data model for something. I can't see the rest of the title. Okay. Yeah, all yours.
Hello there. We're continuing work on ILNP as we have done for the last few hackathons. People present in the room, Rod Grimes, Alistair Woodman, and myself, and a special thanks just to one of my students, Shubh Sinhal, who managed to get some extensions to the Wireshark support for ILNP accepted to the main distribution, which is now available, and that really helped with looking at the PCAPs that we captured in this session. Just as a reminder, the Identifier Locator Network Protocol, ILNP, is a ID locator based addressing system based in IPv6. And as it's an extension to IPv6, there are no tunnels, no proxies. You don't have to worry about NATs, and routing and switching works as it already does. And so do existing applications. So what were we doing in this particular session? We were continuing to test the multi-homing as it works with TCP and UDP. So have path changes made to a client as it talks to a remote server, and that's progressing really well. I've got some graphs coming up. That's quite smooth now. So this is just using TCP cubic with the multipath, multi-homing happening at the network layer. So no real optimizations in the code at all. This is just happening all at the network layer and cubic running on top. 100 millisecond delay or thereabouts, no loss, and the paths were fairly homogeneous, so not a very trying path situation, but nevertheless the performance has improved over the last few hackathons. UDP as well, of course, works. And we're using standard binaries for IPEv3. And the new thing we managed to get to in this hackathon was testing Nginx and Firefox streaming Dash video. Haven't managed to get any detailed measurements on that, but it seems to be working pretty well. And also we're just progressing the code base, Rod's working and progressing the FreeBSD code base to the most recent FreeBSD kernel. This is the setup we had, where we have a server remotely at my lab in the University of St Andrews in Scotland, and then we have a little test bed here running clients. And one of the clients accessed that server, Dash video was running. This is just the tests we did with IPEv as well. So pretty smooth across the 4 paths and the aggregate throughput at the bottom. UDP as well, pretty much as you'd expect. And then Dash video, as I said, we got working as well. Haven't been able to do any detailed measurements on that, but that seems to be working pretty well for multipath also. I'll also be at the Hack Demo Happy Hour and set up in the shared workspace all week if you want to have a chat. Thank you very much.
Okay, great. And now we'll see what that Yang data model is all about. Yes, Yang data model. And after that is VCon. All right. Do the slide.
Thank you. The report from Yang data model for multi-statements of SCID from the Nobuaki. The challenge, we focus on identifying gaps the SCID draft can't address. The SCID draft excel at showing the provenance within the software lifecycle. However, if only one is used, they struggle to represent the hierarchical information flow within software and computing system. The relevant draft in this adjacent domain are the following 3. Therefore, we discussed methods for providing hierarchical information flow for one. What get done? The overcomes were slide hacking and identifying scope, requiring concrete example for each use case. The OCP case study, which is one of the relevant organization, proved beneficial for the initial discussion, and next action became clear. What we learned, the key finding emerged. First, there are no issue with the Skit architecture and the Skit Scala API. So let's looking forward to the RFC beginning publish process. Second, before uploading another draft, we will strengthen the use case section to clear who benefit and when be able to get benefit. Finally, the data structure format need not be limited to Yang, and it is not a mandatory element. However, the field requirement careful design. Finally, wrap. Finally, thank you to everyone who participated in the discussion, and the two individuals who provided the catalyst for the draft growth. Thank you.
Right. Okay. So we have vCon, and after that we have WebBot authentication.
Hi, I'm Dan Petrie. At this hackathon, just like most of the other ones, we try to kind of tick off something that hasn't been well implemented or tested in the vCon spec, and getting down to a smaller and smaller kind of set of those opportunities. Just a quick overview. vCon is it's a data exchange for conversational data, whether it's text or audio or video based conversations, or any combination of those modes. So if you have SMTP messages, or you have Mimi messages, or audio recordings, you can stick them all in this container along with the metadata and analysis like transcriptions and summaries and all that kind of stuff that you might generate relative to your conversations. And it provides this standard data exchange from kind of your conversational platforms to the enterprise that's the consumer of that data. So often it's very useful in kind of contact center situations. So for this hackathon, the focus was transfer and SIP session ID, and mostly on the transfer side of things. So we implemented the kind of some interfaces in the open source Python library to deal with the transfer dialog objects that shows a relationship between other objects. And in a transfer case, you've got an original call, perhaps a consultative call, and then your final target call. And so the transfer dialog object shows the relationships of those other dialog objects, which in the call center context, each of those is a separate recording. And so that part was pretty simple. I spent probably more time integrating this into, we've got an integration of call recording and vCon generation with NetSafety's call center software solution. And so was integrating it into that so I could test it with real data on live calls and that kind of stuff. So got that all implemented, and it seems to work. A couple issues that it kind of helped going through this helped identify was there are cases when you don't have one of those legs or one of those calls recorded. So what do you do to indicate that leg existed, but you don't have any metadata about it or types of things. So that was the primary stuff. Here we've got some more work to do on the session ID, and maybe next time I can finish that up. So that's it for me.
Okay, the WebBot auth is next. And then I have identity crisis after that. Okay.
Hello. I'm Jaime Jimenez. This hackathon, I was experimenting with WebBot authentication and trying to understand it better. So for that purpose, I implemented some of the components described in the draft in the WebBot authentication architecture. So for those of you who don't know what WebBot authentication is a way to have agents use, instead of HTTP user agent strings, sign identification when accessing web resources. Mostly intended for the web, but I think could be also used for APIs. It could be interesting as well. So basically the approach would be to reuse a lot of stuff. I have already some agent experience, so I was reusing that. Then there is implementations of the verifier that Cloudflare share in TypeScript, so porting that to Python. There is some Rust implementation as well. So the goal was to have a simple, minimal implementation, CLI-based, that does all the verification aspects. And initially I was testing against Cloudflare verification endpoint, but then I wanted to also have my own, even if very simple again. This is how it looks like. So the agent will sign the HTTP requests, and it will have this HTTP message signature. This is part of the spec. It's nothing new, basically. Then verification server, if you carry this, I think it's called signature, no, sign agent field, a URL, basically pointing out where the directory server of agents is, the verification server will use that, and then it will validate the signatures. It's very simple. And I got more or less everything to work with the simple agent that you can just trigger this type of authentication. Yeah, I mean, it's not so, I don't know if you can, well, it doesn't show too well as a demo because it's just a screenshot. But basically, I got everything working. I learned a lot. Maybe some interesting takeaways was this new registry that is being made, the syntax, how it can work. There is experiences actually in the constraint space. We have had this directory service as well. And I think there could be a lot of things that could be ported there. Maybe it could be interesting on testing the rate limiting aspects and other information that the agent can receive, and essentially to continue implementing and testing this new technology. And the team was just basically me testing these things, and Thibault, which spent a lot of time also with Q&A, and thanks for that, by the way. And yeah, that's it. Thank you.
Okay. Identity crisis is next. And I see two versions here. We'll go with the second. Okay. Oh, that's weird. Huh. Okay. That explains why we had two.
Hello, everyone. So I have been talking about this identity crisis for quite a while now. In February, I posted in TLS working group a mail stating all the problem of identity crisis. And it's now no longer a theoretical attack, so to say. It's been widely exploited, battering ram, T-fail, and so on. So the core idea basically is at a very high level, just to repeat for others who have not heard this idea, that the client wants to connect to the server as is typical in TLS, but it also wants some guarantees about what software and hardware is running. And from a physical machine perspective, it's the attester which is being measured, and it consists of confidential computing platform. On top of that, it has the coding agent, which actually signs the attestation evidence. And the attesting environment from RAT's perspective is basically the virtual machine for which it is signing that code, which has an identity named identified by priv-ek, which is the ephemeral key, and then it has to be protected from other tenants, virtual machines. That is to say that this virtual machine should not be data should be protected from other virtual machines, which could be from other tenants in the cloud perspective. And the core idea here is that all of it doesn't contain any PKI. Server authentication is straightforward, all broken in the very wider sense of the thing. And that's what we want to have. We want to have PKI along with the attestation evidence, which is to say that if one of them breaks, the other one should protect. So that's the core idea that we have been talking about for a while. The hackathon plan was, as usual, not to talk about or work on ProVerif, which I can also work at my home, was to more discuss the open questions, which came up with the formal analysis. And the involved IDs were all of the ones which are listed. And yeah, people were there to discuss a lot of things. Thanks to all who have been discussing these things specifically. In addition to attested TLS, we also discussed about how we can utilize this work for attested ad hoc, which is already an adopted item in the Lake working group. And Joran and Marco very kindly helped on that to see what differences we need for moving this work into attested ad hoc and what are the differences. We had very good discussions there. Thanks very much. And what we learned is that from attested TLS perspective, of course, attested ad hoc needs a separate analysis. From attested TLS perspective, post-handshake attestation is a suitable choice for standardization, so we can preserve PKI and we can have attestation on top. And what we also discuss is that classical Lewis hierarchy, which is pretty much standard, is not suitable because both ad hoc and standard TLS don't follow that kind of hierarchy. We have one-way authentication, which we will present in the TLS working group, the UFMRG research group, and all the resources are there. You are welcome in the side meetings as well, which I think I skipped this slide. So you're welcome to any of those meetings as well as side meetings. Thanks very much.
Okay, great. So now we have interface to network computing. Yep. Control the slide.
Thank you. Good afternoon. I'm Jisuk Che from Songyungan University in Korea, and my professor is Jeon Paul Jung. For this hackathon, we extended the I2ICF framework. We built an AI agent for an autonomous vehicle that detects obstacles and stops automatically through I2ICF. This slide shows our hackathon poster. Our goal was to make a robot that receives intent, detects obstacles, and stops safely using camera and LiDAR through the I2ICF framework. The I2ICF framework in 3 steps. First, the user intent is translated into network policies. Next, the 5G core delivers them to robots. And finally, each robot detects obstacles, stops safely, and reports back. Our main goal was collision avoidance. We calibrate camera and LiDAR data on the edge to measure distance. When something came too close, the robot stopped automatically. This picture shows our previous I2ICF framework. The robot streamed video and odometry data through OpenCV and ROS2, and the edge used Flask for inference. It was our first connection between robot and edge and the cloud. For this IETF, we added LiDAR process at edge server on the previous I2ICF framework. The blue box shows the added LiDAR process. LiDAR data is sent to the edge, calibrated with camera, and used to estimate distance. If the person is too close, the robot activates the stop functions. This is our demo. First, run these 2 launch files to get data and run the robot server file. And then run Kubernetes server file, edge server file, and robot controller file. Here you can see the log files that they show distance to the person. They also include detection odometry data. We built a real-time perception to stop system. The edge calibrate camera and LiDAR measure distance, and robot stops automatically when it's too close. Next, we'll improve the system to make it faster and more stable. At the next IETF, we'll test 2 robots that share data and avoid collisions together. We'll also design intent and policy translator and create young data models for moving object management. Our code is on GitHub, and the demo video is on YouTube. Finally, here is our team. We thank all professors, researchers, and students who joined this project. Thank you very much for listening.
Okay. So I think that took us to the end of our list. Did anyone have a presentation that we missed? Okay, fantastic. Okay, with that, we'll go back to this then. Yeah, thanks for all those great presentations. I'm sorry that they need to be so short, but in order to get through all of them, that's kind of what we need to do. It would have been great to have more time to ask questions. And fortunately, though, we do have Hack Demo Happy Hour. So that'll be happening tomorrow. And, we encourage you to sign up for that. You do need to sign up. There is the registration link there. In the slides, you can download it. You can also find it on the wiki, the Hackathon wiki. Be sure you sign up as soon as possible would be great. It helps us with space planning, but definitely by 1300 or 1 o'clock tomorrow. That'll be the cutoff because otherwise we won't be able to have a table for you there. And the idea is we'll try to have a table, one of these signboards, so you can at least then, talk to the IETF community about your project and do so in more detail. There'll be some snacks there. There'll be a cash bar and just a good opportunity to have more in-depth discussion. The Code Lounge, I heard some people mention that they plan to be there, or the shared workspace as we call it now. And so that's a good place. These tables won't be here. This room's going to get repurposed, but there'll be, space kind of like this if you want to gather around a table and continue to work on your code. That can be super handy. So make use of that resource. You don't need to book or schedule that. You can just use it as you like. And want to go back and thank our sponsors again. You can also see them on the sign here, but Ericsson, the gold sponsor, and ICANN and CNNIC, both bronze sponsors. Super important that we have them. We really thank them a lot for the monetary contributions that we need in order to do this. Also, I want to give a big thanks to MeetEcho. They integrated in some really cool functionality that made it a lot easier for me to go through all the presentations. Those of you who chair a work group, you may have an idea of what it's like to go through presentations, but going through like maybe 7 or 8 of them is one thing, but going through 40 of them when they're changing on the fly was really challenging. And they added some new functionality that made it so much easier. So that's why I wasn't fumbling around as much as maybe I sometimes do. So really big thanks to them and to the sponsors. Okay, and with that, that's it. This is from, I think, 2019, and we had a great hackathon back then. Some of you are here again, and I hope we get a chance to come back to this venue again soon. We'll definitely have a hackathon at the next IETF, though, too, so I hope to see you there as well. Okay, thanks, everyone.
I'm just jumping into the microphone. Let's all give a big round of applause to Charles and Benno and Barry, who organized this. Thank you for all your efforts.